Good morning. Welcome to the video lecture series of electrical missions. Myself, Dr. Deval Prasad, Assistant Professor, Department of Electrical and Electronics Engineering, Siddhartha Institute of Science and Technology, Puttur. Today's topic is DC missions. The objective of this video is to understand the working principle of and construction of DC mission, characteristics of different DC missions, application of different DC missions. Coming to the electrical mission, so electrical machine is an electromechanical conversion device which converts mechanical energy to electrical energy or electrical energy to mechanical energy. During this conversion process, this electromechanical conversion device will obey the law of conservation of energy. Law of conservation of energy states that the energy is neither be created nor be destroyed during the conversion process or transferring from one form to another form. Based on the input and output given to the electroconversion mechanical device, the electrical machines are classified into two types. So one is generator, another one is motors. The schematic line diagram of electrical machine is shown in figure 1. The input is either in mechanical form or electrical form. So that is given as input to the electromechanical conversion device. So that input is converted into another form that may be either mechanical energy or electrical energy as an output. So this device is known as electrical machine. Coming to generators, generator is an electromechanical conversion device which converts mechanical energy to electrical energy. So the input given to the electromechanical conversion device is mechanical energy. So that mechanical energy is converted into electrical energy. Such type of device is known as generator. Coming to motor, so motor is also electromechanical conversion device which converts electrical energy to mechanical energy. The input given to the motor is electrical energy, so that electrical energy is converted into mechanical energy. Such type of device is known as motor. Coming to the working principle, DC generators works on the principle of Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction states that whenever a conductor cuts the magnetic field, or whenever a conductor is placed in a fluctuating magnetic field, then an EMF is induced in that conductor. In order to explain this, let us considering a simple diagram. So in this we are considering a conductor. That conductor is having two coil sides. So one is coil side AB, another one is coil side CD. One ends of the two coil sides are connected to each other to form a coil. Another two ends are connected to the commutator segments F and E. Two brushes X and Y are mounted on the commutator segments, and a resistive load is connected in between the two brushes. The entire setup is placed on the shaft, which is connected to external prime mover. So now this setup is placed in a two permanent magnets. So one will produce north pole, another one is produce south pole. With the help of external prime mover, once we rotate that shaft, along with the shaft, the conductor is also starts to rotate in anti-clockwise direction. Hence, the conductor sides or the coil will cut the magnetic field produced by the two permanent magnets. According to Faraday's law of electromagnetic induction, an EMF is induced in the conductor, and the nature of that induced EMF is alternating nature. That alternating induced EMF is converted into direct induced DC induced EMF with the help of commutators. That DC current is drawn with the help of two brushes which are mounted on the commutator segments. Hence, a DC current flows through the resistive load. By observing this, in order to generate the induced EMF, we require three things. One is magnetic field, second one is conductor, and the third one is relative motion between conductor and the magnetic field. During the conversion of mechanical energy, the Mechanical energy is converted into electrical energy with the help of this generator. This conversion is based on the principle of production of dynamically induced EMF. The magnitude of induced EMF is given by E is equal to BLV sin theta, where E is induced EMF in the conductor, which is measured in volts, and B is the flux density, which is measured in Webers per meter square, and L is the length of conductor, which is measured in meters. V sin theta is the velocity component, and the direction of induced EMF is given by Fleming's right hand rule. Coming to the construction details of DC generator, the DC generator mainly consists of 5 parts. So one is yoke, field system, armature, commutator, and brushes. So yoke is the outermost frame of the DC machine, which protects the internal parts of DC machine. So it is made of either silicon steel or cast iron. The poles are mounted on inner circumference of the yoke. So that means it will provide a mechanical support to the field system. And also it provides a low reluctance path to the magnetic field. The second part is field system. The field system consists of mainly field winding and poles. The field winding is mounted on the pole core. The pole is divided into 2 parts. So one is pole core, another one is pole shoe. So it is the pole core and it is pole shoe. The shape of the pole shoe is curvature shape in order to distribute the uniform flux, and the field winding is arranged in such a way that it will produce alternating magnetic fields. So once the field winding is excited with external DC source, so then it will carry the DC current and it will produce the magnetic field. So that field is known as main field, and inside that field system armature is placed. The armature consists of armature core and armature winding. The armature core is cylindrical shape, and the outer periphery of this armature core, number of slots are there, and that slots armature winding is placed. The entire armature setup is placed mounted on the shaft, and the armature winding is, ends of the armature winding is connected to the commutator segments. So the function of the commutator is to convert AC induced EMF into DC induced EMF. So once with the help of external prime mover, once the shaft is rotates, so then armature conductors will cut the magnetic field which is produced by the field system. According to Faraday's, an EMF is induced in that field system. The nature of that induced EMF is alternating nature, so that is converted into DC with the help of commutator, which is made up of copper. And the DC current is collected with the help of brushes which are placed on the commutators, which are mounted on the commutators, and which is located on the MNA axis. The brushes are made up of carbon. The function of the brushes is to collect the DC induced EMF, and one resistive load is connected in between the 2 brushes, hence the DC current drives the resistive load. So these are the references taken by this video lecture. Thank you.